I have a little woodworking project. This is an old table made back around 1905, right in 1910, right in there. And this table has a centerpiece that's fixed, and then these legs fold out, and they support a leaf on each side. That leaf is mounted to the fixed part of the tabletop with hinges. And the only problem is I only have one leaf. So that means I had to make another one. So I got some mahogany and glued up a panel and used that for a template, traced it out, cut it out on the bandsaw, and then used a trim router to get it to a nice, perfectly follow the existing leaf. And some edge features here that I'm just not able to duplicate. There is no cutter that I can find that's going to do this edge. So I'm going to have to do a combination of things. One is to use my CNC router and different tools to kind of get as much material out of there as I can, and then sand the rest in, more than likely. But the first thing I have to do is find out what this profile is. It's not a simple arc that I can just, it's not. So I have to find out what this is. And of course, my piece that I had already cut is, I'm going to set that up in the CNC router and use my DRO to find out what all these contours are, which is what I did. So I've got a V-bit in there. It comes to a point, and I set this up so that it is right over the very top corner. And what I'm going to do is move, and in the Y direction, I'm going to move 2 inches at the beginning because it doesn't change much. Then I'll eyeball it with the in the X direction and get that point of that V-bit right over the edge. And then I look at the DRO on my computer, and it tells me what that coordinate is. And so there it is right there, the top two. That first one is 16, and then it's whatever that number was for the X. So then I just move down another 2 inches, and then as I go around this thing, I get it a little tighter because the curve starts getting a lot steeper. And I want to try to keep it so that I have my 3 points that I need for each arc as evenly spaced as possible. So I just keep going around and writing down my numbers, and it's kind of tedious, but I don't have another way to do it. And this seems like it would work pretty good as long as my eye is good enough following that edge around. But it's a piece of wood. The guy that owns this table isn't exactly looking for perfection, so he isn't going to get it. So anyway, I follow this procedure until I get all of my coordinates down. I end up with 9 separate arcs, and all of them have a different radius. Every single one's different, which is why I had to do it this way. I knew they were not going to be the same. Work my way around. This is an enlarged view of the DRO on Linux CNC. Once I get all my coordinates, then I go to my CAD program, and I set it up to put in all of those plot points that I have written down on that piece of paper. That first point down there is on my machine is X0, Y0. So I add a couple of lines for clarity, and then I input the coordinates manually, and I just go down the list that I created and just plot them all in. And in a second you'll start to see them show up. I'm trying to speed this up. I don't want it to be too long. So once I get all the points in place, all those coordinates that I picked up from the CNC router on the DRO, I will be able to tie those together with 3-point arcs. And as you can see, I just do 3 at a time, starting from the last one of the previous arc, and work my way around until I have the profile complete. The next thing I have to do is add a couple more lines, and then I'm going to remove all those points. They won't work with the next thing I have to do. They have to be out of there. So now I have to export this as a AutoCAD file, a DXF or a DWG, either one. I use DXF because the next program I'm going to use needs to have one of the two to bring this in, and it will be the CAD cam. So I'm giving it a different file name, and I'm terrible at file names. So this is Vectric Aspire, and it is a full CAD cam. I could have done this, I think, on this, but it's just easier for me to use my old CAD program. So much quicker. And then I import it into Vectric as a ready-to-go file. So all I got to do is create a toolpath, which would be a profile toolpath, which is very simple with Vectric, and I'm going to have a 0 depth of cut because all I'm going to do is with this first program is run it on the CNC machine and watch that V-bit follow that contour and make sure it's following the edge of that piece of mahogany as closely as I can. I mean, it's just a piece of wood. So I got to do the same thing here. I have to save it where it says profile 1. I'm going to change the name of that, but that is the actual Gcode. It created the Gcode, and so I'm going to save that to an NGC file, which is what Linux CNC wants. That's the type of file it wants, and I can change some of the settings in there so it when it actually saves the file, it puts stuff in there that I want. So now I'm going to test it out on another program called Commodix, and with this one I can actually manipulate the cutter and follow it to make sure it's going to do exactly what I want it to do. Vectric will do that to a certain degree, but you can't really do what you can with this. So once I decide that the file is good, we'll go to the machine and I load the file into the machine. And I got to find it first. I got so many damn files on this disk. By the way, this is Linux CNC. It's an older version. I've had it for quite a while. It works fine for me. And you can see my old zigzag pattern in there for where I was locating my coordinates. So this is the arc, and I'm ready to run the my follow program. So I'm going to try to get the camera in there close enough so you can see whether or not it follows that edge very well. I'm a terrible videographer. My lighting is crap, and this camera is not a really good camera, but I'm not going to whine about the fact that I can't get a GoPro or a DJI because you have to have the right phone, otherwise they won't do business with you. Bastards. Anyway, you can see that it's following the edge of that, that's what I want. Now there's actually 9 different arcs in this sweep because they're all different. So as it comes around, I'm carefully watching. What I'll eventually do is flip this board end for end, put it in the same position, and make sure that this same arc is going to work for the other side. I can only cut half of this table at one time because it's too long. I have 24 inches in the X, and this table's 33 inches long, so I got to make it in 2 cuts. So when it comes back, when it comes around, I think it looks good enough to me to go with this, but I like I said, I do have to flip this board over. Then I have to do other things. I have features on both sides of this this piece of wood I'm going to use, and I can do it all with that same arc that I created. I just use tool offsets and that sort of thing to get where I want to be. So anyway, that's how I do a uneven profile, a custom profile on the edge of a part like this one with using a CNC router and the DRO. As always, thanks for watching, all 12 of you.